So what we're going to do today is I'm going to walk you through this, how to build out these a simple Golang application that you can use to expose some APIs. This application that I'm building, the example that I'm building is a trading application. And so I'll make some assumptions here real quick. Just going to go through, kind of show you all the files. I've already got some of the files set up, and then we're going to be actually building out the middleware. Database should already be in place. So I've got a MySQL backend. If we log into that, we can see that the database is already there. We're going to go ahead and switch over to the database that I'm using here and show you the tables. Okay, so 3 tables. I've got the SQL file here included, which will create those tables and actually pre-populate it with some data, so you have something to play around with. All right, so let's jump over and let's go ahead and get started. So you can see here I've got the basic skeleton of a Go program. I'm just going to add some real simple stuff to it. It's pretty straightforward. So let's go ahead and get started with that. So, all right. So first things first, I don't like to hard code stuff into my files or into the source code. So you can see here I've got a properties file. It's YAML format, just a little bit easier, I think, to read visually. It's, everything's laid out. Yeah, you can see the password there. What I did is I don't check this file into GitHub. I check in this this template file, and so that'll save you from having to hard code the password. I'm sure there's other ways to do that, which a lot of different ways to skin this cat. Okay, so let's actually, the first thing we want to do is we want to get those properties into our main function here. So, all right. So first we're going to have to create a struct. If you're not familiar with that, what a struct is in Go, Google's your friend there. All right, so. Yeah, I've already actually created this file. I'm just copying stuff over from another Scratch file here. So let's see here. All right, so we get this configuration in here. This is the struct. So this is going to contain all the properties that we want from this properties file. We're going to read this into this CFG, into this config variable. And then what we can do is, once we read that file, we'll load this up from the properties file, and then all of these will be available throughout the code. All right, so you can see here I'm calling a read file function. So let's go ahead and get that in there as well, and I'll show you what this does. Yeah, so save that. You can see Visual Studio Code's telling us we're missing a few things here. Specifically, we're missing all the packages that we need to be able to read and manipulate this data. So let's go ahead and get those in. Let's go ahead and get those added in. So the first one's missing is the OS. Actually, what I'm missing is the Actually, what I'm missing here is not the package. I missed the first line of that function. So just bear with me. All right, so once we format that correctly, we save that. Visual Studio Code is going to automatically set up the packages that we need here. You do have to use go get in the command line, which looks like so. Standard go here. Anytime you're using a package, you have to run that, which basically will download that package into your local file system and make that available to use in your code. So we've got another function here, process error. Obviously we don't have that in our code yet, so let's go ahead and get that in, save it, and see where we're at with this. All right, so we've got the basic structure in our main. We're creating a configuration and we're reading that file. At this point, we shouldn't see any errors, but let's just go ahead, see where we are with this. Yep, no errors. So when we run this, nothing's going to happen, but there's no errors at this point. So all right, let's actually connect to the database at this point. This is going to we need a few more structs for the database, and we need we're going to add in the connection string as well. So all right, here. All right, so before we go too far, reading important from the properties file, which I showed you before. This database connection string, creating this. Basically, this is a string, and I'm reading from that properties file: database username, database password, database host, database port, database name. And if we just jump back over there real quick, we can see all of those: username, password, port, host, name, etc. So Visual Studio always complains, or Go always complains, if you use if you declare a variable but you haven't used it yet. So that's what all these here are. Since haven't finished the rest of the code where we're using these. All right, a little output. So when the program starts, the application starts, we actually can see, we get something on the command line showing us that it started and what port that it started up on. So that's pretty useful. And all right, so I'm gonna add a couple things in here. So what we have here is this is our actual, this is the actual connection. So when we do SQL.open, it'll create the connection and save it into DB. Any errors in that connection are going to get put into the error variable here, which is a error data type. We're going to check, as long as there's no errors, we keep going. If there are, we just print out the errors to the screen, and then we show, okay, MySQL database connection established. So what we could expect here, all right, now I created database as a global variable, so let's go ahead and add that in so we can we don't get that complaint anymore. All right, so we can comment out this for a second. There we go. So since we haven't included the MySQL package yet, so let's go ahead and get the right package in there. All right, so now once that's in there, we build. All right, so there we go. So we got a connection established and our application started. Just kind of, as soon as it starts, it dies. but which is obviously not what we want. But I'll show you next step here. Once we uncomment this and actually build this function here, then we're going to basically create a listener that will stay active until we close the application. All right, so let's get started here. Let's see. All right, so first let's create the additional structs that we know that we need. Just being picky here, I typically like my structs to be at the top here after this global variable. Keep it neat now, it'll be a little bit easier to debug later. All right, so we've got three more structs that we want to add here. Let's get those in, and I'll explain what each of those are for. So each one of these is going to match or correlate to the tables. So we'll have a user struct, which we can all right, so you see here we got two fields in the user table. We got two fields in the struct. Same with stocks, and then same with orders as well. All right, so you get the idea there. So we have our structs. We have the data structures that once we read in the data. Or once we read in the data from the database, or once we connect to the database, we have an object that we can store, that we can put the rows into. So let's go down to, we were going to create that handler. All right, so remember down here, we call this function handle request. We need to create that. So let's go ahead and create that now. We'll just put it down here at the bottom of our functions. All right, so no errors there, but this function is not doing anything yet, obviously. So what we want to do is we want to create a new router, and the router is what is going to basically be our service, our listener. This is going to be the APIs. This isn't the actual routes, but this controls the sets that up and defines what that router should look like. Mux is a package in Go that provides some really handy services. All right, so it's complaining that router is not used. We'll go ahead and take care of that now. So I'm just going to create, at this point, I just want something real simple. And I'm going to create a first route, which goes to, so the way that, so router handle function, you give it the endpoint or the URI, and then this calls the function. So we're going to have to define that in a second too. But I want to add one more thing real quick. Okay, so this actually creates the listener. Listen and serve TLS. I'm passing in the server port, the certificate, the key, the router. So this here is going to let us use TLS. The router is what associates these functions to that listener. And then the port obviously is what port do we want this listener defined on. And if you take a quick peek here, we're going to put it on port 10,000. So, all right, let's take care of this homepage error, or that error real quick. So what we need to do is we need to create a function that matches that, and it's going to be really, really simple here. So at the end of our structs, so function homepage, we're going to pass in a response writer, we're going to pass in the request, and all we're going to do is we're going to return to, so this format fprint, this is going to return to the API request, and then format print line, that's going to go to our console down here. So at this point, let's just do a quick visual check, no errors. Let's compile. Great, so we're still connected. Now on port 10,000. So let's see, we bring up a and we go to localhost. Because it's HTTPS. All right, so the security certificate is expecting a different host name. So let's actually use that instead of localhost. There we go. So no errors, certificate's valid. Actually matches the host name used by the client or the browser. And welcome to the home page. We can go back to our function real quick, and we can see that's exactly what we were expecting to come back. And that's exactly what we were expecting in the output of the console down here. All right, so what I'm going to do now is I'm going to add one more function. I'm going to add one more route, add one more function, and then I'm just going to add everything else in real quick. Not going to walk through, once I get past the second round, I'm not going to walk through it, but it's all going to be available. All this is available over at GitHub, but you can get to it, clone it, and take a look there. So let's just add one more. What I'm going to do now is I want to see what stocks are there. So let's go ahead and add in one more router. One more function. This is stocks. The function is return all the stocks, and we can even specify what method is allowed here, which is great, because they'll actually return an error if someone connects to it and tries a different method other than get. All right, so save that. Obviously, we know we haven't created the return all stocks function yet, so we're going to go ahead and do that real quick. Okay, so just pasted that whole function in. There's a lot there. Let's go through this real quick. So same deal here. We're passing in the response writer. We're passing in the request. I want to go ahead and for the response writer, I want to go ahead and set that we want the return content type to be in JSON format. We have a couple logging statements here. Now we're going to create a new variable, which is an array of that stock struct. So let's take a look at that. So it's, like I said, it's an array of stocks. So all of our stocks will go into an object in that array, and then in this format here, ID, symbol, name, price, which matches up to what we see down here in our database table. So see, the query is real simple. All we're doing is just select all from stocks. Nothing fancy there. Just give us every row, every column that's in that database. If this query doesn't work, if there's a connection issue with the database, just go ahead and break out of the program. No sense in continuing because it's probably something serious is going on. It's not gonna correct itself. The nice thing about using the SQL package is when it fails to create a connection, it'll automatically retry to create a new connection. So that's pretty cool thing about the database, the database MySQL package. All right, so let's see. Okay, so what we do then, once we get the results, we're going to step through each row that we get back and drop that into our into our struct, and then we save it into the stocks variable. So what we end up passing back in JSON format in the request, in the response, what we send back is that variable, which was the struct with our with all the data from the database. So let's see. Let's save that. Again, no obvious errors. Good breaks. We've got to recompile. All right, we'll start it back up. Connections established, and let's go ahead and get Postman up here. And we already got it here. Let's see, direct to the application. So you can see here it goes to app.trader.tradergo.io, port 10,000, to the stocks endpoint. We run that. We get back exactly what's in the database. So again, pretty straightforward at this point. We've got about 138 lines of code, not even with line breaks, everything else. Really simple way to create these APIs. So let's go ahead and, like I said, I'm going to just do the rest of it real quickly, just to get the rest of it in there. So the rest of the routes that I'm going to add all correspond to things that we want to do, things we want to interact with the database. All right, so we've got select all users, create a user, return or select all orders, create orders. Same with stocks, same with return all accounts or return a specific account. And that means the accounts is the users that I've got. In the future, what I wanted to do is actually expand this so that users can correlate to accounts, and accounts, a user can have multiple accounts. Typical trading application user, having multiple accounts associated with their profile. So save that. We get a bunch of errors, not unexpected at all. Let's just go ahead and add in everything at this point. So we've got all of the routes. And now I went ahead and I added all of the corresponding functions, functions for each of those. Not getting any errors. Recompile once again. Pull up Postman. Having a little socket issue. All right, so clearly what I did here is a little typo. Let's get that corrected. Yeah, there we go. So accidentally deleted that. Once we save it, all right, so that's a little bit better. That's what we were expecting. Double check. Now we're seeing all the stocks again. Get all users. So we can see all the users come back. And so this is going to return all of the stocks that this user has already all the orders associated with this user. So that's pretty much it. That's the application. Did not take us very long. Did not take us very many lines of code to get this application working. Like I said, all the code's up at GitHub. The link's going to be in the blog post. I'll put it in the release notes as well, or not the release notes. I'll put it in the notes with the video so that all that's available, no matter where you get to this video from, whether it's straight to YouTube or through the blog post over at toomey-tech.com. Thanks for watching. Any questions you have, just send me a comment or send me an email. Thanks a lot.